Hey guys, so today I'm gonna be working on a VLSM variable length subnet masking lab. Um, I've already started here, just had already this kind of setup to explain how I kind of run through everything. Um, so yeah, I'm gonna use these steps here. We're also gonna uh, end up trying to ping the computers to each other, the PCs to each other, the end hosts. So, okay. Um, First step is to subnet the 192.168.5.0/24 network to provide sufficient addressing for each LAN. Also, the point-to-point connection between R1 and R2, which is this connection right here, the G000. Okay, so let's start by subnetting the network. I have this here set up. Okay, so um, first off, I kind of already organized it here. I actually forgot to write the hosts for these. 14 and 9. So I'm just gonna write that down here. 14 hosts and 9 hosts. Okay. So the way that I've subnet these is the way you should subnet them is to go from most amount of hosts, the subnet that needs the most hosts, down to the subnet that needs the least amount of hosts. So basically from largest to smallest. So in this case, LAN 2 is the largest, LAN 1 is the second, LAN 3 is the third, and then LAN 4 is the fourth, which is why I organized it in that fashion over here. Okay, so in order to figure out the subnet mask, we have to find a subnet that can accommodate 64 hosts. To do that, we can uh, move our uh, our 1 bit over from in the prefix length in the binary version. Um, in the actual subnet mask, we move it to the right by 1, and we do the calculation of 2. I want to just write it here, 2 to the power of the host bits minus 2. So the host bits are basically going to be, let's say we have a /25, so our network bits would be everything from the 25, which would be right here, all the way up to here, and then the 7 remaining bits would be our host bits. So yeah, so okay, so if we did, for example, I'm just gonna do it here, the calculation, so we can do power 2, 8 minus 2. So if we do all 8 host bits, we get 254 hosts. That is too many hosts. So we're gonna actually change this here. We're gonna put this, maybe let's try with a 7, which would make it a /26 subnet. Also, it's a /24 subnet. I did not write that. I mean, it's over here. /24. It's also a Class C address, which is also why it's a /24. Starting with a 110, also 192. It's in that IP address range. It's a Class C. So the default subnet mask is a /24. So we're gonna go based off that too, because even if you have a Class A, you can still go up to /24. It's just the way it's calculated is a little different. Okay, so yeah, so here we can have 126 hosts, usable hosts. Let's try the 6, giving our network bits an extra bit and removing 1 from the host bit. So we get 62 usable addresses. So we know this is not enough. So we know we need at least 7 host bits. So in this case, we're gonna do 126, right? So 126 is the amount of usable hosts we have in this network. Um, and so our network address here, well, our network address is going to start exactly where this is at, as the slash 4. So we're going to do 192.1 dot, sorry, dot 168 dot 5.0. And we said we had over here we had 7 host bits, so that gives us a slash 25 network. Because we have 7 host bits here and we have 25 network bits, so it is a slash 25 slash 25. Okay, so our broadcast address, what we're gonna do, the way I calculate my broadcast address is that I'm gonna take this. We have our network bit. It ends here. And this whole section is our host bit, right? So what we're gonna do is everything that's in the host section, the host bit section, we're gonna turn it into we're gonna turn it into 1. So we're gonna give 1 to all of these host bits, right? Um, and so now we're gonna do the calculation. So if we have 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, because these are all of our host bits. And we also add the bit that's in the network bit for the broadcast address, but in this case, the network bit is a 0, so we're not going to add that 128. That gives us 127. So now we know that our broadcast address is going to be 192.168.5.127. That's our broadcaster's address, right? Because all of our host bits, when we turn them into 1, give us a 127. It actually also makes sense. Like if you have this 0, I mean, it's also where this stops, right? So, uh, so the next subnet is gonna basically start at 128. So this is that empty bit right there. So you're gonna basically add 128 to this, but that 128 is gonna be the next subnet. So it's like 128 minus 1. So our first usable address here is going to be, we're just gonna add 1. So let's bring this all back to 0. And so we're just gonna add 1. We're gonna add 1 each time. Well, we're just gonna add, yeah, add 1 bit. So we're gonna go 1, in this case, and then so our first usable address, we're just adding the 1, right? And it gives us 192.168.5.1 slash 25. That's our first usable address within this subnet, which is the slash 25 subnet. And our last usable address is going to be one right below the broadcast address, which is 126. So we have 92.168.5.126 slash 25, right? Okay, so we basically have this information for the slash 25 subnet, the subnet for LAN 2. We have 64 hosts available. So our network so we're going to move on to LAN 1, and our network address for LAN 1 is going to be the next one up from the broadcast address of uh of uh of LAN 2, right? So our broadcast address is, in this case, was 192. It's kind of like I mentioned here. You're just gonna add 1 to the broadcast address. So you're just gonna add 1 there. So in this case, if you add 1 to 127, you're gonna get 128. So I'm gonna change it here just to make it a little visually better. So we're gonna add 1. So now this is our new network address for LAN 1, right? So we have 192.168.5.127. 1.128, and we're basically going to do the same thing. We're going to try to figure out how many hosts we can, how many host bits we need cleared, or how many network bits we need basically for this subnet. Um, so for the subnet mask. So in this case, we're going to do the same thing. Down the same formula. Do power of 2. So we know that 2 to the 7 gives us 128. But it's actually 128. But we have to subtract 2 because we have the network address and the broadcast address, which are not usable. So we have 2 to the power, so we can keep going. So now we know that this one gives us 126. When we did 2 to the 6, right? We do 2 to the 6 and we subtract 2. That gives us 62 hosts that we can use. So that looks like enough to me. But just to double check, we can even try switching this over to a 5, just to double check. 30, that's not enough hosts. So let's bring this back to 6. So we have 62 usable hosts. That also means that this is a /26 because now we're adding one over here. I mean, if we were to have the 255, 255, we're just going to be adding one to the last one. I'm not going to do all of that here because, I mean, this is just for my own purposes in a way, just recording this. But, okay, so now we have a /26 network. And, okay, so now that we have a /26, we're going to do the same thing, right? So our /26 would end right here because it's 25, 26 network bits. We're going to take the host bit portion of this address and we're going to convert it to a 1. So 1, 1, 1, 1, 1, 1, 1, 1. And okay, so now we can basically add. So now, as you can see, we have the 128 on the network bit. We're gonna add it all together because our broadcast address is gonna be the addition of all the host bits plus the network bit, plus what is left over here on the network bit. So we're gonna go. We're gonna do 128 plus 16 plus. Sorry, wrong calculation. 28 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 gives us 191. So now we know that our broadcast address is 191. So we're going to go 192.168.1.191 because when you switch all of these to ones and you add in that network bit, it gives you 191. I'll change this back to 0 real quick. This is going to be a /26. Oh, did not mean to do that. Let's do 192.168.1.191/26. Okay. We have total usable here. We have 64. Oh, sorry, 62. Because okay. Same thing. We're just gonna add 1 bit, 1 plus 1 to the network address to find our first usable address. So we're gonna do 198. 168.1.191. Sorry, the 192/26. And the last usable, we're just going to take one out of the broadcast. So 191.168.1.192. Oh, sorry, 190/26. Okay, so we have this one figured out. Same thing on the LAN 3. It's going to be the same process. So we have 192.168.1.129 for the network. Oh, sorry, .191. Sorry, I messed up here. This is 129. I did not notice I did that. 129. And over here we have 192.168.1.192 as our first address. So we're gonna do that. Okay, same thing. We're looking for 14 hosts, right? So we're gonna go to here again, power 2, comma. In this case, we had 6 host bits. Let's try with 5 host bits. Minus 2 gives me 30. Okay, so that gives me 30 hosts, usable hosts. And what if I do 4? Gives me 14 exactly. We are going to stay with the 30 hosts just because um it's better to be a little bit over, in my opinion. So we're gonna stick with this. Also, it allows room for like if you need to expand the network for whatever reason. Maybe you need to add an extra 1 host. You don't have to like redo all of this. It's better to do it like that. It's flexibility gives you more flexibility. Okay. So we're gonna do the same thing over here, and we are going to now we have five host bits. So we have 1, 2, 3, 4, 5 host bits, right? So we have 5 host bits. Uh, that gives us 25, 26, 27, a slash 27 IP address range. Sorry, prefix length. I said IP address range. I'm just saying things. Prefix length. And we are going to figure out the broadcast address. So now we have a slash 27. So that gives us all of these turn to 1. And let's switch this 192 over here real quick as well. 92, and we have the 128 and 64 gives us 192. And so same concept. We add all of these up. 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1 gives us 223. So that is our broadcast address. 192.168.1.223/27. And our first usable, we're going to add 1 to the network address. We have 192.168.1.193/27. And our last usable, we're going to remove 1 from the broadcast address. We're going to do 192.168.1.222 and /27. Okay, and total usable addresses we have, it's 30 usable addresses. That's our /27. And LAN 4, we have 9 hosts. If we do same thing, power. Power here. 5 to the 2. Blah, blah, blah. That's what was already there. So we're gonna do 2, and let's do. In that case, we had 5 host bits, so we're gonna do 4 host bits just to check, and that gives us 14. If we do 3 host bits, that gives us 6. So that is not enough. So we're gonna go with uh, the 4 host bits, which will give us a prefix length of /28. So we have 14 total. And we have a /28, and our network address is going to be 1 above the broadcast address, so it'll be 192.168.224/28. And then over here, we're going to have our broadcast to be 191.168.1. So our broadcast address, what had I said it was going to be? Oh, our network address here is not 224, sorry. Our network address here is 193. No, wait, it is 224. Yeah. It's 224. Um, broadcast address here is, let me see, we have, oh, it would be 224 here. I made a mistake. Sorry. 224, 128 plus 64 plus. Okay, so we have all of this. And we have this would be a 0. Okay, so our broadcast address is actually a little different than what I thought it was. It was a mistake. 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1 gives us 239. So our broadcast address is actually 239, 239 slash 220 slash 28. Our first usable address would be 225. So we're going to do 192.168.1.225, first usable, slash 28, and our last usable would be 192.168.1.238 slash 28. Okay, so now we have the configuration for our LANs. We're just missing the point to point. I'm just going to write it down here. Point to point. And I'm going to go net, oops, broadcast first, last, and total. Okay. So our point to point, we really just need one host. If I'm being honest, it's just two. Actually, we just need two, because we have two interfaces here. So we're gonna use two hosts, one for each router interface, in this point-to-point connection. So we just need, I'm gonna write here, two hosts, and we're gonna do the network address. In this case, would be a continuation here, same thing. So it would be 191.168.1.240. And so we're gonna do the same type of math. We're gonna do equal power to the, let's say, 6. Sorry, 3 minus 2 gives me 6. Gives me 6 usable hosts. Okay, we can maybe get it a little bit more specific so that we have, let's see if we can. Okay, this one gives me exactly 2 hosts, 2 usable hosts. So we're gonna use the slash 30 because I'm sure if I go, yeah, if I go 2 to the 1, it's not gonna give me enough. So, okay, we're gonna go a slash 30 here. So we have 2 host bits. We're gonna do slash 30. And the broadcast address is going to be the same concept. So now our network address is 240. 240. So we're going to add the 16 now. 64 gives us 240. Yep. And okay, so we have we only have 2 host bits, so this 8 is going to be a 0, and this 4 is going to be a 0. And we only have these 2 host bits, which give us 3. So our broadcast address is actually going to be 243. Yeah. This would be 191. Say dot 1.243. That's our broadcast address, and our first usable would be 191.168.1.241 slash 30, and our last usable would be 191.168.1.242 slash 30. Okay, Yeah, we have a total of uh, two usable host addresses. Okay, so we have all our addresses already set up. This is kind of how I like to figure it out. Makes it a little bit easier. Usually I would have a bunch of writings here, but just for the sake of this lab and demonstration, kept it a little simpler. Again, this is mostly for me and to show what I've been learning. Okay. So I'm gonna put this here really quick. Okay. All right. So we are going to start assigning the first usable addresses to each PC in the local area network. Okay. So we're gonna do. Actually, I'm also gonna set the. I'm gonna the next three steps say assign the first usable address to the PC in each LAN, assign the last usable address to the router's interface in each LAN. So the last usable address would also be the gateway, which we can see here in our global settings. So I'm also going to be adding that as I add this. I also have to obviously add them directly to the interface on the router command line. But okay, let's start with PC1, right? So PC1 is in LAN 1, so we're going to look at LAN 1. And our first usable address would be 192.168.1.129, right? And as you can see, it's going to try to give you the default subnet mask for class C, for a class C address, which is a /24, which is why we get the 255.255.255. It's basically every bit filled out here. Every bit, every you add up every bit, it gives you 255. But we are actually on this one, we're using a subnet mask of a prefix length of /26, which means that we actually have a value over here as well. In the case of a /26, we're talking about 128 and 64 added together would give us 192. So we're gonna add so our subnet mask would be 255.255.255.192, which is equivalent to a /26 prefix length. So we're gonna set that up there, and our default gateway, we're gonna just set it up now. So it's asking for the last usable address to the router's interface in each LAN. So in LAN 1, our last usable address is the 191.168. Sorry, the 192. I don't know why I wrote 1 here, but it's 192. 192.168.1. I'm actually going to change it here because it can get a little confusing. 192. I did it a couple times actually. It's kind of funny. So because I'm talking a lot. Yeah, it's 192. 192. I don't know why I wrote 191 anywhere. It's crazy. 192. 192. 192. That's exactly how mistakes happen, but it's all good. Caught it. So I was doing it. Okay. So for LAN 1, our last usable address is 192.168.1.190. Okay, so that's our first PC setup. We can close this. Let's do PC2, which is LAN 2, which is this first LAN right over here. And we're gonna do, yeah, PV4 address. The first usable one is 192.168.5.1. It's a /25. So over here we're gonna have us 128 because /25 means we have one bit on the 128. And then we're gonna go into the default gateway for this one, and it's gonna be 192.168.1. The 5.126, and that's PC2. PC3, we're gonna do the same thing. So that's LAN 3. First usable is 192.168.1.193. And our subnet mask, this one would be a /27. So we have 25, 26, 27, which gives us 224. So our subnet mask is going to be 224. And we are going to go into the settings and set up the default gateway, which would be 192.168.1.222. And that's PC3 and PC4, which is the last one. We're going to go fast Ethernet 00 because that's the connection between the switch and the PC. And we're going to go 192.168.5 dot 5 dot I also realized I made another mistake and I probably wrote it down over there like that too. Let me see. Yeah, I did. That's terrible. 5 and this one would be 5. Okay, I did write 5 there. I wrote 5 here. Silly mistakes. 5 and this one would be 5 as well. Yeah, I don't know why I wrote 1 on all of them. Whatever. 5 and fast Ethernet 5. Okay, and PC4. Okay. So we're gonna do, yeah. Well, so we know it's 5 as a third octet, not 1. 192.168.5. This is the first one, so we're gonna do 225. And the subnet mask would be /28, which gives us 125, 26, 27, 28. Gives us over here. So that gives us 240. So we're gonna do 240. That's that subnet mask. Okay, and we're gonna do the default gateway, which is the last address, which is 192.168.1.22238. And we have 255.255.255.240. Okay, and that is it. Over here. Oh, we don't need the DNS here. Sorry, I don't know why. And I also put a 1 again. Okay, perfect. So we have all of that set up. So now what we want to do is to configure the interfaces on the router. So we're going to do that real quick. And config, and we're going to do interface G. Let's start with G00. G00, and we're going to do IP address. And so for LAN 1, it's going to be the last usable. So we're going to do 192.168.5.190. 190, and the subnet mask is going to be 255.255.255.192, because that is the /26. Boom. And we're going to do no shut. And this changes it to up, and we can do show IP int. So we can see here for this interface, we can see gigabyte internet 00 up, and we have the 192.168.5.190 set up as our internet address. Okay, so we're good there. So let's do G01 as well. So we're just going to do in G01, and we're going to do IP address. So that's LAN 2. We're going to do the last usable, which is 192.168.5.126. And we're going to do 255.255.255.128 because That's our network bit right there for that subnet mask, the prefix length. And we're going to do no shut because Cisco routers, their interfaces are shut down by default. So we always have to make sure that we turn them back on, reactivate them. Okay, so we're going to do show IP in, and we can see here, oh, that's 00. Do show IP in G01. So we can see here, 192.168.5.126/25. That's our /25 because we have the 225.225.225.128 subnet mask. And yeah, so these are good. These are all set up. And we're going to do the same thing on R2. Also, we can do another quick little check here, actually. We're gonna let's just do show IP and I mean we could have just done it from there, but we can also see 192 gigabit 01 190. Let's double check it. Gigabit 00, which is LAN 1. We have 190. That's the last usable. Yep. And then we have 126 over here for LAN 2. Yep. Gigabit Ethernet 01. Yep. So we're good there. All right. Let's exit out of here. And let's do the same thing over here. And let's enable configuration terminal, global configuration mode, and do interface G00. And we're going to do IP address for LAN 3 is going to be the last usable, so we're going to do 222. And remember, this is a 5, not a 1. So it's 192.168.5.222 for LAN 3, and we have a /27 subnet mask, which gives me 224. So we're going to do 255.255.255.224. And we're going to go straight into G01, and then we'll check them at the end. I'm actually going to use a different method to turn them on. So 192.168.5 for LAN 4 would be .238. And we have 255.255. This one's a /28. So we have 25, 26, 27, 28, 16 right here, which gives us 240. So the mask is 240. And then we're going to do interface range G00 to 1. And we're just going to do a no shutdown, and we're going to turn both of them on. So what this does is that it just selects, selects both interfaces, G00 through G01. And now they're both up. And we can do a quick do show IP enter. And we can see gigabit Ethernet is up. Oh, sorry. And it's 00, and we can see 01 is also up with the address set up. And as a matter of fact, let me double check because so yeah, we have 5 on both of them. Okay, so we're good. So all the interfaces on both routers are set, and now we are going to configure the static route over here. So we're gonna have to set up the, and I probably should have done that before, but it's okay. We're gonna set up the G000 interface. So we're gonna go into we're gonna do interface G000, and so the address for we only have 2 available hosts. So this is R1. We're gonna start with the first usable, so which is 192.168.5.241. And the subnet mask is 255.255.255, and in this case it's 30, right? So we're going to do 25, 26, 27, 28, 29, 30. We're going to add all of these together, which gives us 252. So gives us 252. Oop, the 252. Oh, and I forgot to write IP. Okay, and let's just do a no shut. It's still going to show down in this case because on packet tracer, uh, both interfaces between routers have to be activated for it to show up. So it's just going to show down until we activate the other interface on R2. I know on Cisco devices, real world Cisco devices, it'll change to up automatically. But this is not the case here, so we got to activate it on both of them. So we're going to do that now. You can see that it's already set here. And we're going to do the same thing over here. We're going to use the second address. These are part of the same subnet because this is the point-to-point connection. So they're not part of this one or part of that one. This is its own little subnet right here between both routers. So we're going to do interface 000, and we're going to do IP address 192.168.5. Use the last usable, which is 242. 242, and then 255.255.255.252. And we're going to do the same thing, no shutdown. And now we have this change state to up, as you can see, because now they're both activated. So we're going to do, yep, they're both up. And we can also do, there's another way to just check the interface. Not so much the IP address and the status of the actual address, but this is a more general overview of the whole interface. We can do this just do show interface. You can see everything here. General address is 192, or you can just do show IP interface, which is the long version of the brief one that we just did. So it gives you a bit more detail on that. Okay. So from there, we are going to start setting up the static route. So we basically here we need every computer configure static routes so all computers can ping each other. So the way I do this is sorry. I like to do for me I just connect coming from either of these computers, I want to redirect it to these networks, to these subnets, right? So when I do IP route, I'll set my destination to the network address of this network. So I will do LAN 3. So our network address would be 192. So this is when because PC1 already has its default gateway set to this one, so it's gonna send a packet over to R1, and now we just have to get R1 to be able to communicate with the other network, which does through the router. And so we have to route our IP. We have to route our packets statically in this case to R2, so that R2 can redirect it with its interface through its interfaces, because it'll have that subnet already configured into its interface, into its appropriate interface. The switch will be the one that, with the MAC address, will address the packet directly to the end host. So we're gonna route it to that subnet. So in this case, the LAN 3 subnet is the network address. It's 192.168.5.192, and subnet mask is .255.255. So again, slash 27, 25, 26, 27. That gives us a 224 at the end, not a 225 like it would try to put on the 255, not a 0 like it would try to put on the, if you do it here. And our hop is going to be right here for me. So this is where G000 is going to want to hop over to G000 on the other router. And actually, I just realized that I'm on router 2. So this is actually the opposite. So we're going to do 192.168.5. We're going to hop it to LAN 1. So let's do 128. And subnet mask is going to be 255.255.255.255.224. Sorry, not 224, the 192. And the hop is going to be this G00 here. And we know that that 00 there is going to be 241 because it's that first usable address. So 192.168.5.241. And we can show the IP route. Let's double check it. Ooh, sorry. Not in privileged exact mode. And we can see that 192.168.5 is reachable via this interface right here. So yeah, we're gonna do the same thing for the other subnet, which is LAN 2. Via the same 192.168. Okay, and let's double check it again. Great. Okay, so we have R2 already set up to be able to hop over to R1. Whatever packet is being sent from either end host. So now we're gonna do R1. So here we're gonna do P route. We're going to LAN 3 now, right? So we're gonna do the network address 192.168.5.192/27. Again, 25, 26, 27. That gives us 224. So 255.255.255.224. And it's going to use the G00, the second usable address here, because it's just point to point. We know it's here. So it's going to be 242. So it's 192.168.5.242. Boom. And that is done. Double check. I always like to double check. There it is. 192 via 192.242. Okay. And we're going to do the same thing for the other route. So IP route 92.168.5. What's this one? LAN 4, the 224. So the 224, and it goes 255.255.255 dot 240. And it's gonna hop same spot. So okay, and then let's make sure that it routed correctly. Okay, so we have local connections. We have 2 static routes. We have a connected route and we have a local route. Awesome. Okay. So, oh, by the way, connected route basically means in this case, what was I gonna say? Oh, so the connected route, at least in the case, for example, R1, the connected route is that it means it's directly connected to this network. Um, it basically like will take in anything from this switch. Like if you had another PC here, because it's directly connected to this route, it would be able to you know, this is the it'll be able to basically receive anything from this network. Um, it will take the packet. Um, the 126/32. In this case in 01. I meant to be on 01, but uh, what that means is the interface. It's a local connection. So that is the interface, this interface that we set up here. Um, so yeah. Okay, so we are going to test now. So now we're just going to test. We're going to go into the desktop here, command prompt, and we're going to ping. We're on PC1, so let's ping PC3 in this case. So that's LAN 3. We know their address is the first usable, so 192.168.5.193. It's going to ping. It might, because of ICMP, echo replies and echo requests and echo replies, it's going to time out. It's going to, yep, there we go. So if we try to ping again, it should just go through this time. Yep. And we have made connection with LAN 3. And it should be the same for LAN 4. We're just going to test it out real quick just to check. 192.168.5. I hate that I wrote 1 over there because it is a little confusing, but it's okay. So we're going to do 225 because it's the first usable. And it's going to do the same thing. And there we go. Seems good on that end. And yeah, so that means everything's working fine. If we try from PC3 to PC1, same outcome. So yeah, so that is this whole lab, and yeah, learning new things. It's awesome.